Hello. My partner
Oily.
and I will guide you on a tour of Gazpromneft Omsk Lubricants plant, which is the most modern production site in Russia. We will show you the production of base oil Group 1 according to API and final products, packaging process and laboratory operation. Base oil production is the starting point in the manufacture process of final lubricants. Oil distillates and tar are supplied from vacuum distillation unit of Omsk refinery plant to the lubricants plant. Tar pumps to the deasphaltization unit for production-based oils. Then, deasphalted oil and oil distillates will be supplied into a two-stage treatment unit. Solvent extraction, the process that extracts unwanted elements and components which would adversely affect the parameters of the base oils. And dewaxing process, where low-temperature characteristics are being improved. After all refining stages are passed, final base oils are produced. It is supplied into raw material storage tanks. The base oils are mixed with the additives for the production of the final lubricants. Additives are transported from stock in a liquid form in 200-liter barrels to the dosage and heating unit, where they are heated up to the required temperature. After heating, the barrels are sent to the dosing pump unit. Dosing is as follows. The operator rolls up the barrel and starts the process. The sleeve is lowered into the throat of the barrel, and the predetermined volume of the additives is pumped through pipes to the premixing unit. Some additives are supplied in a solid form. Usually, such additives are viscosity improvers. Therefore, they must be dissolved in the base oil with the use of strong mixers, disintegrators. This operation is necessary to facilitate their involvement in the preparational scheme of final products. The preparation is performed through the dosing system and premixing units, equipped with counters. Using several indicators, these counters control the dosage process of components which simultaneously flow into a common pipe. This is called flow mixing. The components are poured into tanks for final mixing. Tanks are installed on the strain gauge scales. The weight in the reactor is compared to the initial preset value, which allows the controlling of leakages or losses. Such tanks are used for production of bulk quantities of final lubricants. The production process is a non-stop regime. The full manufacturing cycle of lubricant production from start to certification takes from 12 to 15 hours. After the manufacture process is finished with the previous cycle, the line can commence production of some other grades of oils. All pipes equipped with self-cleaning systems. A piston moves inside the pipe using compressed air and collects residuals of the previously manufactured products from its walls. Production system management is controlled by an operational center. The technology manager starts the production procedure. Then, the system operates automatically, and final lubricants will be supplied to the packaging line. Now we are moving to the rechargeable hopper. This is the place from which a fully automated production of canister filling starts. The hopper is filled with granulated plastic. Then the compressed air is forced into the extruders, where the canisters are produced. The expanding canister is blown up from melted plastic into its form. After cooling, the canister is filled with lubricants in the turntable unit, and a lid is screwed onto it. The inductive sealing machine pressurizes the throat with a special purpose foil. After sealing, the canister is labeled. The laser device applies the manufacturing date and batch number. The machine places several canisters into a box and seals it with melted glue. Then, before palletizing, the box is weighed and labeled. The prepared pallet is wrapped with stretch film to enhance its protection, and a special label is applied. The pallets are delivered to the warehouse. The warehouse can store up to 10,000 tons of product. The narrow passage logistics is used to the designated area. Due to the first in, first out serving principle, the customer always gets high-quality lubricants with maximum storage life. The certified plant laboratory performs analytical control of the raw materials, main components, and co-products. It performs also the certification of the final lubricants. Due to physical and chemical property analyses, the laboratory ensures additional control over the process flow during manufacture. Let's take a closer look at the laboratory operation on one example of the determination of 3 values. Here, the total base number is measured with an automated titrate unit. The higher the number, the more stable engine oil is towards acids, mixing with it during the fuel burning. Moreover, a higher total base number enhances the protection ability of oil against deposits on the engine parts. Here, the ability of grease to remain confined within a friction unit under impact of water is assessed. A standard bearing is filled with lubricant and is flushed using a hot water jet for 1 hour. The water washout stability of the grease is assessed by the remaining amount in the bearing joint. Here, the temperature is determined at which the oil loses its fluidity. The sample is gradually cooled down to the temperature at which it becomes non-fluid in an inclined glass tube. This indicator is of importance for shipping and for filling up the equipment with oil under low ambient temperatures. The modern equipment of the laboratory is also used to determine the following parameters: kinematic viscosity, flash point, foamability, demulsibility, cleanliness code, spectral analysis, anti-wear characteristics, density. The laboratory performs more than 120 method tests. Let's review more thoroughly the determination of certain important indicators and their meaning to the end consumer. The viscosity determines the fluidity and pumpability of the oil under different temperatures in a friction unit. At the Omsk Lubricants plant, it is measured by an automatic viscometer. This reduces the measurement time and ensures enhanced accuracy compared to a common capillary viscometer. These viscosity indicators allow car owners to understand that the oil will preserve its fluidity at low temperatures and ensure optimal lubrication during engine run. The flash point is determined by an open cup method. It points at 2 important indicators for manufacturing and shipping: fire safety and volatility. The ability of the oil in preventing foam formation at high rotation speeds directly affects the continuity of the oil film in a friction joint. If the foam is trapped by the friction unit instead of pure oil, this can result in accelerated wearing of parts, overheating, and oil oxidation. Cleanliness code is one of the most important indicators for hydraulic oils. Gaps between parts in hydraulic systems are very small, and they're extremely sensitive to contamination code. Therefore, hydraulic oils need thorough filtering during manufacture and operation. To determine the cleanliness code, the oil is passed through a counter where laser analysis is used on the sample. The size and amount of contamination and opaque particles are determined. Manually, this analysis would take more than 1 hour, but now only 10 minutes is needed for it. Demulsibility properties of the product are its ability to separate water which may penetrate into the lubricating system during operation. The mixture in the oil tank has enough time to settle, and the oil without water returns to the lubricating or hydraulic system. This indicator is especially important for oils in contact with water or steam. The spectral analysis is performed during quality inspection of the ready oils and additives. It allows the determining of chemical composition of a sample. This is a sort of prompt analysis to control the proportions of components and additives at oil manufacture. This analysis is also used to determine the authenticity of products in disputable situations. The set of additives in oil is like a fingerprint. It is individual for every oil. Thanks to the spectral analysis, one can assess the content of metals and other components in the oil. The most important low-temperature parameters of oils are determined from the dynamic viscosity at cold temperatures. The first analysis, simulation of the engine cold start, allows the determination of the minimum temperature at which the starter is still able to start the engine. With a mini rotary viscometer, MRV, the minimum temperature is determined at which an oil pump can push the oil into the engine without causing oil starvation. Anti-wear and anti-seize properties of lubricants in the friction units under different loads and rotating speeds are determined by a 4-ball friction machine. 3 metal balls are tightly fixed inside, and the 4th ball rubs against them with a specified frequency and speed. The friction unit is filled with oil or lubricant. In a specified time, wear scars are formed on the balls at the points of rubbing. Better anti-wear and anti-seize properties of the oil mean smaller wear scar diameters and higher welding loads. This means better protection of equipment parts under real operating conditions. A modern laboratory is an integral part of any high-tech production. It is of crucial importance to follow every stage of the production process, since any deviations in indicators can point at an error in the process flow or at a failure of equipment. This allows maintaining continuous production and timely shipments of high-quality products.